Hello, everyone. Today I want you to imagine something very simple. Imagine you're sitting next to a swimming pool. It's a nice day. The sun is shining. The water is calm. Then suddenly somebody jumps in. Splash! Right away. The water is no longer calm. Waves start moving everywhere. Some waves are big, some are small, some move fast, some move slowly. Now maybe another person jumps in, and another, and soon the whole pool is full of messy, wiggly waves going in all directions. Now imagine something funny. Imagine there is a tiny, very clever bug sitting on the edge of the pool. This bug can't see the people. It only feels the water. But just by feeling the waves, the bug can figure out who jumped in, where they jumped, and when they jumped. The bug feels the pattern of the waves and says, someone jumped over there a moment ago. That sounds amazing, doesn't it? But that's almost exactly what your eyes and brain are doing all the time, because the world around you is full of waves too. Not water waves, but light waves. Light is bouncing off everything. The walls, the floor, the ceiling, your hands, your face, and even the air. These light waves are going in every direction at the same time, just like the messy waves in the pool. And yet, somehow, you can look at one thing and see it clearly. That's the real miracle. Your eye is like a tiny little hole that lets light in. Only the light coming from a certain direction gets focused nicely. Light coming from the side doesn't get focused very well. That's why your side vision is blurry. Try it. Look straight ahead and notice what's happening on the side of your vision. You can see movement, but not details. Now turn your eyes. Suddenly it becomes clear. All you did was move the little hole that collects the light. Inside your eye, the light hits a special screen called the retina. The retina turns the light into tiny electrical signals. These signals go to your brain. And now your brain has a big job to do. It has to look at all these signals and say, okay, what do these waves mean? And in less than a second, your brain tells you, that's a person, that's a chair, that's a tree. Remember the bug in the swimming pool. The brain is like that bug. It feels the waves and figures out what happened. Except your brain is doing it with light instead of water. Now, here's something even more interesting. Light waves come in different sizes. Some are very short. Some are longer. The size of the wave decides what color you see. Short waves look blue. Medium waves look green. Longer waves look red. But there are also waves longer than red light. These are called infrared waves. You can't see them, but you can feel them as heat. Some animals can actually see heat. There's a kind of snake called a pit viper. It has a special heat sensing organ on its face. At night, when it's dark, the snake can still see a mouse because the mouse's body is warm. The snake is seeing the heat waves. So while we are blind to those waves, the snake is not. And the waves don't stop there. There are even longer waves called radio waves. These carry music, voices, and signals from all over the world. Right now, in the room you're sitting in, there are radio waves from other countries, signals from satellites, and messages from airplanes. You can't see them, but they are passing through you. There are also much shorter waves, like X rays and cosmic rays, coming from space. They pass through your body, through walls, through the earth. All these waves are the same kind of thing, just different sizes. So in the same space, at the same time, there are light waves, heat waves, radio waves, and space waves all mixed together. It sounds like chaos, but somehow we can still see clearly. How do we do that? It's like tuning a radio. When you turn the knob, you choose one station. The other stations are still there, but you don't hear them. Your eyes and brain do the same thing. They tune into the light waves coming from the thing you're looking at and ignore the rest. That's why you can look at a friend and see their face clearly, even though there are thousands of other waves bouncing around the room. Your brain is doing something very clever. It is solving a giant puzzle made of light waves. Now, here's another trick your brain does. You have two eyes. Each eye sees the world from a slightly different angle. When your brain combines these two pictures, it can tell how far away things are. That's how you see in 3D. Try this. Hold up your finger and close one eye. Your finger jumps to a new place. Now open both eyes. It moves back. Your brain is using the difference between the two views to calculate distance. This is why you can catch a ball. Your eyes see the ball moving. Your brain predicts where it will go. And your hand moves to the right place, fall in less than a second. Now think about how strange this really is. Light is bouncing off everything in the room. Some light is going left, some right, some up, some down. Light from one person crosses light from another person. Waves pass through each other without crashing. They just mix together and keep going. It's not like arrows hitting each other. It's more like invisible shaking in space. The space itself is wiggling, and your eyes are feeling that wiggle. Even though it sounds messy, it works beautifully. You can see many people at once. You can read words. You can recognize faces. Your brain sorts the waves into meaning. All this information is floating through the air all the time. We just don't notice it until we build tools to detect it. A radio turns invisible waves into sound. An X-ray machine turns invisible waves into pictures. Your eye turns light waves into sight. Nature is full of information. The universe is like a giant library of waves. When you look at a tree, you are not really seeing the tree itself. You are seeing the light that bounced off the tree and entered your eyes. Your brain builds the picture of the tree in your mind. So the world you see is not exactly the world itself. It is your brain's best guess, based on light waves. And that's not a bad thing. It's actually wonderful, because it means we can understand how it works. Once you understand this, the world becomes even more amazing. A simple room is no longer simple. It's full of invisible motion, invisible messages, invisible energy. You're sitting inside a storm of waves, but it's a very gentle storm. Every second, trillions of waves are passing through you. Some tell you what color things are. Some tell you how warm things are. Some carry music. Some carry messages from space. And your brain calmly says, "Ah, yes, I know what that is." That's the real magic. Not that we see, but that we understand how we see. So next time you look at something ordinary, a chair, a tree, a friend, remember that you are decoding an invisible dance of waves. And that dance has been going on long before humans existed. And it will continue long after we're gone. The universe doesn't care if we look at it. The waves keep moving, but we care. And that's what makes science beautiful. Because when we understand how nature works, even simple things become extraordinary. And that, my friends, is the real fun of imagining.